Hello, welcome to this channel. My name is Enoch. Today I'll be starting a series on networking, for DevOps engineer, maybe you're a cloud architect. This can be very, very useful for you. As DevOps engineers, networking skill is a must-have. CI/CD pipelines often requires configuring network resources such as, setting up DNS entries, opening port, setting up IP address, and you'll be also working with a lot of cloud infrastructure provider like AWS, Azure, Google Cloud, and this platform involves extensive use of virtual networks, subnets, routing tables, security groups, load balancers, VPN, and so on and so forth. Understanding networking will help in configuring this component effectively. So if this works for you, you can join me. And I will be looking at computer network. I will try to explain what computer network is, and we will look at component of computer network. We'll look at the characteristics of network. We'll look at the classification of network based on geography. Then we'll look at OSI model. We'll look at encapsulation and de-encapsulation in the OSI model. Then we'll look at layer 1 of the OSI model. We'll try to look at how to convert decimal to binary, which will be essential for to understand subnetting, IP addressing, supernetting. So we'll go from layer 1 to layer 2 of the OSI model, and we'll go to layer 3, where we are going to treat the elephant in the room, which is the IP address subnetting. And from there we'll go to layer 4, where we are going to be treating port numbers, TCP, IP protocols, and from there we'll go to the upper layer of the OSI model, which are the 5 layer 5, 6, and 7, and we are going to look at domain name service. We are going to look at the dynamic host configuration protocol, and we are going to finish with network commands. So let's get right to it. For this particular video, I think we'll be stopping at layer 2, and in the next video we will start from layer 3, where we are going to treat IP address and subnetting. So what's a computer network? Every device being used on the network will have an IP address assigned to its network interface. Like your laptop, we have a network interface card or an Ethernet adapter. Your smartphone, we have a wireless adapter. And these network enabled devices, as used in input and output devices, will have network interfaces, and because of these network interfaces, these devices are able to exchange data or communicate. So we can simply just say that computer network is a communication between two or more network interfaces. And if you look at component of computer network, you have 2 or more computer devices has to be involved. Then you look at cables or wireless network to link the computer devices together. You look at your network interface card, which the cable will be connected to, or which the wireless network will be connected to. You have your computer, which is a device that knows what to do with the data that is receiving over the network. Then you have your switches, to connect multiple network interfaces together, and you have your routers, which is routers are used to connect multiple networks together, and you have your software called operating system, running on the device that can analyze the data it is getting from the network and present it, to the user. So, what are the basic characteristics of a network? First thing is topology. Topology is just simply the way is how devices are connected to each other. It is the arrangement of devices and how they are connected in a network. And the next one is latency. And latency is just the time delay between sending and receiving of data, and it's typically measured in milliseconds. If you go on a web page and you search for maybe Amazon.com, and it's loading, and it's not opening quickly, that's what we call high latency. Is the time delay between sending and receiving, of data. And low latency is crucial for real-time application, like video conferencing, gaming, and so on and so forth. So high latency can cause delays and affect user experience. So throughput is just the actual rate at which data is successfully transmitted over the network, which is typically measured in bit per second. If you're trying to download something and you have tried to download maybe something on the internet and is very, very slow, that's what we call low throughput. What you want on a network is low latency and high throughput. That means that the network is very fast and is very effective. You can download things quickly, and you can visit any site, any web page, quickly. So another characteristics you look at in a network is cost. When we are looking at cost, you will be thinking of high availability, where you have to over provision. You have to over provision so that so as to avoid any point of failure. So we will double up on some of the critical components, so that if any single component fails, at least we have an alternative component that will still be up and running. Another characteristics of a network is security, and it's just a measure to protect the network from unauthorized access. And it can include encryption, it can include firewall, and intrusion detection system. And another one is scalability. You want to design the network to scale as users grow on your network without requiring a redesign. You are 1,000 today, tomorrow you can be 2,000. Do you have to do a redesign? That's what scalability is all about. People visiting your site today can be 100. Tomorrow, if you are 1,000, will you have to redesign? Something like that. So you also talk about reliability, which you want to make sure that your network is reliable by selecting reliable components and implementation of best practices. So what are the classification of network based on geography? It's simply the classification of network based on the distance between the network interfaces, that are communicating with each other. For example, your laptop, has a network interface, and Google has a network interface, and the distance between them defines the classification. So you have your local area network, which is your network maybe within maybe a room or maybe a small hall, where the network devices are connected with each other, probably with a cable or some kind of other devices. You also have your wide area network, which an example of that can be your internet. You have your metropolitan area network, which is like a metropolitan city or a municipality which has computers and they are connected in a network, or your metro train computer network system. You also have your campus area network, which you have computers connected together in few acres of land. You have your personal area network, which can be your Bluetooth, your hotspot, which has a very small range. All right, so let's look at our OSI model. This OSI model is Open System Intercommunication Model. It's a model that was created, it's a communication model that was developed by the International Organization on Standardization in 1984. And it's a conceptual framework that helps lay out how computer networking protocols should work with each other. It standardized how computers communicate with each other over a network. So it's a 7-layered approach to data transmission, which divide the operation into specific related group of action at each layers. So you have the first layer as the physical layer, you have the second layer as data link layer, you have the third layer as the network layer, the fourth layer as the transport layer, You have the section layer as the 5th layer. You have the presentation layers at the 6th layer, and you have your application layer at the 7th layer. So that's that. And what are the basic elements of a layered model? First one is service. A service is just a set of actions that a layer offers to another layer. Usually a service, a layer serves the layer above it and is served by the layer below it, and not the other way around. So for example, network layer, which is the 3rd layer, handles the routing and addressing of data packets, which are necessary functions for the transport layer, that's layer 4, to deliver data between hosts. And you also have your protocol. The protocol is a set of rules that a layer uses to exchange information. We all are familiar with protocols, right? Your HTTP protocol, your F5 transfer protocol, your SMTP protocol, your SSH protocol, and so on and so forth. So an interface refers to the communication between adjacent layers within the same system. So now in the first layer, you have your data as bits. In the second layer, you have your data as frames. In the 3rd layer, you have your data as packets. In the 4th layer, you have it as segment. It will have been converted to segment. In the 5th, 6th, and 7th layer, which are the upper layer of the OSI model, you have your data as data. All right, so let's look at encapsulation and de-encapsulation. I know encapsulation and de-encapsulation processes refer to how data is prepared for transmission across a network, and how it is processed at the receiving end. And the process is fundamental. The processes are fundamental to how data travels through the layers of the OSI model. And encapsulation basically is the process of adding headers and trailers to the data as it passes through the layers of the OSI model. If you look at it starts from the encapsulation process starts from layer 7. If you are sending an email or you're sending an HTTP request, it will start from layer 7 and it will go down to layer 4, where the source and the destination port numbers will be added. Then it goes down to layer 3, where the source and destination IP addresses will be added. Then it goes to layer 2, where the MAC addresses, or where the source and the destination MAC addresses will be added, and it goes down to layer 1. So layer 1 is the last layer in the encapsulation process. So each layer had its own information called an header, and in some cases a trailer. A trailer is just a frame check sequence which is used for error checking during the transmission of data, is to ensure that data can be transmitted and understood by the receiving device. So we have the de-encapsulation process, which is the reverse of the encapsulation process, where the headers that were added will be removed, from layer 1 up to layer 7. So the encapsulation process starts from layer 1. As soon as the data gets to the receiving device, the encapsulation process will start, and it will start from layer 1. At layer 2, the MAC address will be removed. At layer 3, the header for the IP address will be removed. At layer 4, the header for the port numbers will be removed, and so on and so forth. It will get to layer 7, and the information will be presented maybe as email address or a website that has been requested. So that's that. And layer 1 is just responsible for the physical connection between device and a network. And like I said, at layer 1 is the last stage of the encapsulation process, and it converts bit into signal and transmit them over a network medium like Ethernet cable, fiber optics. No header or trailer is added at this layer. And layer 1 is the first stage of the de-encapsulation process, where the physical signals are received and converted back into bit and passed on to layer 2. for further processing. And the protocols or technologies that work in layer 1, are the Ethernet, which is and you also have your Wi-Fi, your Bluetooth, your universal serial bus, and so on and so forth. And you have your hubs as part of the hardware component of layer 1. You have your cables, you have your repeaters and modems. So informations are in bits in layer 1, 0 and 1. And computer works with this bit to process information. So let's try and understand this bit. I decided to address it so that I just want you to understand how to change decimal to binary, because you are going to need it when you get to IP address. For you to be able to do IP addressing very well and subnetting very well, you need to. I think you need to know how to just change from decimal to binary, and vice versa. So a bit, short for binary digit, is just the smallest unit, of data in a computer, and it can hold two possible values, 0 or 1, and a byte is a group of 8 bits. 8 bits, that means you have maybe a 0 in 8 places or 1 in 8 places, or you can have them mix. The possible values are zeros and 1. And byte is the basic unit of data storage in computers. You have your kilobyte, your megabyte, your gigabyte, and so on and so forth. And a single byte can represent 256 possible values, from 0 to 255. Let me bring out my notepad and let me show you something. When we say 0 to 255, the binary value of 0 is 0, 0, 0. Those are in 8 places. Those are the binary value. And the binary value of 255 is 1 1 1 1 1 1 1 1. And you can get the binary value of 100, binary value of 106, and so on and so forth. I even put some in this place, so you can see I said an example here. The binary of 106 is 0110110, which is 1 byte, which has a decimal number of 106, and which is between 0 to 255. You can see that. So a byte, a single byte can represent 256 possible values from 0 to 255. So that's that. And let's look at how to convert binary to decimal. In decimal there are 10 possible choices: 0 1 2 3 4 5 6 7 8 9. So if you are it will be increasing from 1 to 10, from 1 to 10, 10 to 100, 100 to 1000, 100 times 10 is 1000, 1000 times 10 is 10,000, 10,000 times 10 is 100,000. It will increase, with the value of 10 like that. But in binary, we only have 2 choices, which is 0 and 1. So it will be increases in multiplication of 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, 128 times 2 is 256. But we can stop at 128 because we are talking of byte, which is just 8 bits. So if you want to convert your 236 to binary, you can use this. 256 out of 236 is how many 256 will you get in 236? Is 0. You have 236 remaining. How many 128 will you get in 236? Just once, and you have your 108 left over. How many 64 will you get in 108? Is just once. Then you have 44 left. How many 32 will you get in 44? Is just 1. You have 12 left. How many 16 will you get in 12? It's just a 0. It's a 0. You still have your 12 left. How many 8 will you get in 12? It's just 1. And you have your 4 left. How many 4 will you have in 4? It's just 1. and you have your 0 left. How many 2 will you have in 0? It's a 0 and you have your 0 left. How many 1 will you get in 0? It's a 0 and you have your 0 left. So if you take it from the 8 bits, you have 1 1 1 0 1 1 0 0. So that's it down there. So the binary format of 236 is 1 1 1 0 1 1 0 0. So if you want to get a decimal value back, just every value that has 1 at the bottom, that just add them together. Now 128 has 1, so 128. 64 has 1, so plus 64. 32 has 1, so plus 32. 16 has 0, so 16 is not there. 8 has 1, so plus 8. 4 has 1, so plus 4. 2 has 0, so 1 also has 0. So you know, so if you add these ones together, it will give you 236. And I give another example. Okay, I just add this slide so that in case you are confused with my example of how to convert decimal to binary, you can use this example. But I believe that the other example will help a lot, especially when we get to IP addressing. You know, there are a lot of reasons why I use this. I like this particular way of converting. Now, if you try to change your 179 to binary, you take 128. Take 128 out of 179. How many 128 are we going to find in 179? It's just 1. Then you have 51 left. 179 minus 128, you get 51. How many 64 will you have in 51? 0. You still have your 51 left. How many 32 will you find in 51? It's just 1. And 51 minus 32, you get 19. How many 16 will you have in 19? It's just 1. Then you have your 3 left. 19 minus 6, 16. How many 8 will you find in 3? 0. You have 3 left. How many 4 will you have in 3? 0. You have 3 left. How many 2 will you have in 3? It's just 1. You have 1 left. That is 3 minus 2. How many 1 will you have in 1? Is just 1 and you have your 0 left. If you ever get anything apart from 0 at the remainder at the end, then that means you have made a mistake. It should always be 0. So that's that. So your binary for 179 will be 10 11 0011. And if you want to get your value back, if you have a binary, you want to get your value back, just put them under this particular 128 to 1, just like this, under this sequence. Put them under it. Everything that has 1, add it together, and you get your decimal value. Like this one 128 has 1, so we add 128. 64 has 0, we will not add 64. 32 has 1, so we add 32. 16 has 1, so we add 16. 2 has 1, so we add 2. 1 2 has 1, so we add 1. Add them together, you get your 179. Just note that, please. We will need it when we get to our IP addressing. All right, layer 2. In layer 2, data is basically formatted into frames. It's formatted into frames, and header is added, and trailer is added. When the header is added, then it add the source and destination MAC address, which is the address that you find on your network interface card or your Ethernet adapter. It provides physical addressing, error detection, and correction, to ensure reliable delivery. So protocols involved in layer 2 is just your Ethernet, your address resolution protocol, your point-to-point protocol, and so on. And hardware components that are working in layer 2 are the network interface card, your switches, which is what you use to interconnect multiple devices together in a local area network. You have your wireless access point to working in layer 2. You have your layer 2 switches with virtual LAN support. You have your bridges, so on and so forth. So this is where we are going to stop for today. And in my next video, we are going to go to layer 3, and we are going to look at IP addressing. We are going to look at subnetting. This is very fundamental to be able to understand IP address, how to choose IP address, and how to understand subnet and subnetting. So I hope I will see you in the next video. Thank you for watching, and see you.